Okay, we've established our X and our Y, and let's just take a moment first to understand the idea behind linear regression. Okay, so what I want to do here is I'm going to put in a new text header, and let's just say review linear regression. Okay, so what is linear regression? Well, let's do this using a little plot here. And so what we're going to do is we're going to do just an example of 2D linear regression plot to help explain what's going on here before we do the machine learning. Okay, so how do we do that? Well, let's import, we'll do this quickly, matplotlib.pyplot as plt. Okay, and then we're going to do import seaborn as sns, and we'll do sns.set. Give that nice gray background with white grid lines. And now we're going to just go and do a quick sns dot, and then is it I think it's a reg plot. Yeah, reg plot, regression plot. And so to do this, you can say, I think that they want you to add data equals df, and then x. Okay, now for traditional two-dimensional linear regression, we've just got to pick one of the columns, unfortunately. And so we can think about, what might be really useful to predict the house value. Well, I would think the income would be very useful here. Okay, and y then, of course, is what you're trying to predict, and that we've already established is our median house value. Now, because this is inside of this sns.regplot, it's not going to, it's the same y anyway, so we should be fine. And then let's just look at this, and then let's talk about it for a minute. So this plt.show will put it up there. Okay, so here we have a regression plot, and you can see there's really a lot of, a lot going on here, right? You can see there is sort of like an upward trend. We learned something valuable too, which is that the data seems to peak out at about 500,000. I think before you do machine learning, it's good to do full data analysis on your data set. But the point here is that the answer that we're looking for, if this was a two-dimensional problem, is this line. Okay, so basically this line, it's the least squares line, it's as good as you can get. And the idea with linear regression as machine learning would be, well, look, if you were only using these two values, right, 2 dimensions, using just one value of x, you could say to predict this other, well, this is what you would end up with. You would end up with this line. So with machine learning, though, the idea is, can we, in fact, sort of add more, x's, so it's not just one dimension. We take all the other columns. Now, if you add just one more, you could imagine it would be 3D, then not 2D. Instead of a straight line, you'd have what's called a hyperplane. And that's what it is in higher dimensions. So the idea is this. We're taking all of these columns and we're putting them together as our inputs. Because it's more than 3 dimensions, we're in a higher dimensional space. But in effect, what we're trying to find is it's a hyperplane of the higher dimensions. In linear regression, it is absolutely a straight hyperplane, okay? And so this is ideal when your data is in fact linear, which it usually is not. But the reason why we're starting with this is because linear regression is sort of the most mathematically accessible. Now let's just go over a minute how this is working. It's hard to get exactly what's the equation of this line. We're not going to get into that now. With this, we'll get that later when we do our machine learning model. But if we look at it a little bit, it looks like, as the median income goes up by 2, say, between 8 and 10, well, this house value looks like it goes up maybe 80,000 or something. So maybe we have something like y equals 40,000 times x is our model, What we're looking for here when we're building out are the multipliers, which is the 40,000. So, and the other thing, it doesn't go through 0, 0, it looks like, and that could or could not be set. Okay, so that's sort of the gist of it. We are going to find, using machine learning, we'll talk about what it does and how it's a little different, to actually figure out the regression hyperplane in higher dimensions. And if you have linear data, this could potentially be a really good model. And if you don't worry about it. We just try it out, and then we'll look at future options a little later.